Hello, my name is Mohammad Izwan bin Othman. I will cover the topic from week 1 until week 4. Our group member is Mohammad zulqarnain bin muthaza. He will cover the topic from week 5 until week 7. And lastly is Ahmad amirul afiq bin Mohammad fauzzi. He will cover the from week 8 until week 14. This presentation is based on our whole semester PLC subject. Firstly, I will explain what is the PLC. PLC is a programmable logic controller. It is usually used for industrial automation. This controller can automate a specific process, machine function, or even the entire production line. Next, I will explain about the objective. Our objective for this presentation is to understand about the ladder logic instruction. Ladder logic instruction consists of normally open, normally close contact, series connection, parallel connection, and the output. The second one is to familiar with the Omron CP series, which is CP1E CPU unit. There are two classes of CPU unit that we learn. Class E for basic model and class N for application model. Last but not least, to demonstrate ladder diagram using CX Programmer. The latest CX Programmer is version 9.7. For the first week, we have the industrial talk by Festo Detective. The talk are run through Zoom meeting at 29 March. And it is explained about the PLC, pneumatic and hydraulic application in the industry. We also need to do the mind map about the talk, and the mind map is consists of application and advantage for each system. In the second week, we learn about the lesson plan and activity for previous semester. There are three types of CLO, which is cognitive, affective, and psychomotor. For cognitive, it is about the knowledge that we get from the subject. Psychomotor for the modern tool usage. For the last one is affective, and it is about the individual teamwork while doing the assignment. The third week, we learn about chapter 1, and we are doing a self-learning pre-lab activity. There are several industries that use this PLC system. For example, oil and gas, wind turbine, cement industry, and smart factory. 5 functions of PLC in oil and gas, which is control and monitor valve switch, regulate the flow pipeline, monitor temperature and previous pressure, alarm function, and data transfer function. The wind turbine is used to help wind turbine. It used to help wind turbine more efficient and experience less downtime. Next, PLC system diagram consists of application, input module, PLC output module, and power supply. The input device has push button, switch, and sensor, while output device has solenoid valve, motor, lamp, and alarm. For the pre-lab activity, we learn the step-by-step to check the I/O in memory reference of CP1E CPU unit. To do that, we open CX Programmer, and in the head menu, we click the I/O memory reference, and at selected CPU unit, choose CP1E. In the memory reference, we can see all channels for CP1E that we use to do the ladder diagram. In week 4, we learn module and standard operation procedure, discuss a pull question and previous pre-lab. To starting a new file for CX Programmer, we have to click the CP1E at device type and choose E20 for CPU type. The interface for CX Programmer consists of step number, rung number, CPU type, and load section. There are two types of safety and health precaution. The first one, is called a dominant off. In any emergency condition, if we press the stop button, the system will stop immediately. The second one is we have to press two switches simultaneously to operate the motor. It will make sure that our both hands are secure from the machine. Next, the hardest instruction for me is the counter. This counter is count the number in descending order. There are two input for counter, which is count input and reset input. For count number, it is between 0 until 255. Other than that, it will become error. The set value is from 0 until 9999 in BCD mode. This is the example for counter. When the sensor detects 3 times, then it will light up. If we press the stop button, the system will reset the count. For example, the sensor is detect 3 times. One, two, three, and the lamp will light up. Next, if we press the stop button, the system will reset, the lamp will off, and the count will reset to 3 BCD mode. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Mohammad zulqarnain bin muthaza. Saya akan menerangkan sedikit mengenai apa yang kami telah pelajari daripada week 5 sampai ke week 7. So dalam konten dalam week 5 ni yang kami telah pelajari adalah daripada ladder diagram, ladder logic dengan basic logic function. Okey, saya akan terangkan sedikit apa dimaksudkan ladder diagram. Ladder diagram ini diberi nama sebab dia bentuk dia macam tangga dan kiri dan kanan dia adalah orang panggil adalah bus bar. So saya akan lukiskan macam ni. Okey, di sini adalah salah satu contoh. Sini adalah kita akan letak 24 volt VDC dan sini adalah konsol volt. So di sini ini kita panggil bus bar dan horizontal ni kita panggil dia rung untuk circuit lah. So ini contoh detail yang saya katakan tadi. So di sini akan disupplykan sebanyak 24 volt dan di bahagian kanan ni represent untuk 0 volt. So yang di sini adalah rung, mewakili rung, ni adalah rung kosong dan sini adalah step. Okey, untuk sesi kami kali ini, kami menggunakan Omron CPU1E dan CPU kami adalah E20. E20 ini bermaksud output dan input yang kami gunakan, iaitu 20 input output. Okey, 20 output input tu kalau diberikan di sini adalah 20 input output. Dia melalui channel kosong saja. Dan kalau output dia channel 100 melalui range 100 sehingga 100 0.7. Dan sini adalah 0.00 hingga 0.11. Okey, untuk kegunaan internal relay ataupun self holding, kita boleh gunakan selain daripada channel-channel yang saya sebutkan tadi lah untuk mengelakkan kekeliruan. Okay, inilah salah satu basic untuk logic instruction yang kami gunakan untuk pada run. Okay, ini ada load node dan output. So load yang tiada palang ni boleh dikatakan sebagai normally open dan ini adalah normally close. Okay, fungsi dia sama seperti switch. Apabila kita tidak menekan satu switch untuk di on, so dia akan berada di normally open. So apabila kita tekan switch itu ataupun kita nak hidupkan satu benda, dia akan berada di keadaan normally close. So output ni adalah kita punya load lah. Apa lagi macam lampu, kipas semua tu. Ini adalah simbol dia punya represent. Okay, ini adalah basic function untuk basic logic function. N adalah seperti ini. Ini adalah N. Kenapa dipanggil N? N adalah bila load secara series. Ini N. O pula bermaksud dia secara parallel. Okay. NOT ni adalah not. Not maksudnya dia kan tadi kata normally close. So dia ada macam ni. Bagi N not ni adalah gabungan O dengan not. So dia mesti ada salah satu daripada ni adalah normally close. N not pula macam N tapi dia ada normally close. Okay, itu untuk week 5 yang kami pelajari. Week 6 pula kami telah diberi pendedahan mengenai case study untuk beberapa simulation. Dan salah satunya adalah cara mesin ini berfungsi. Okey, kita akan go through sama-sama untuk soalan ni, untuk case study ni. For the safety reason, machine are often set up to ensure that a machine can only open if the operator pressing two switch. Okay. Simultaneously. One by right and one on left. This is to ensure the boss operator hand will be on the switch and cannot be in machine when in operate. Okay, ini more pada macam safety lah. Dia soalan dia kalau nak lebih senang faham, dia nak bila dua-dua switch itu ditekan serentak barulah motor itu berfungsi. Ini maksud sini kita akan detail dulu. Dia ada dua switch sebab dia kata dia nak bila dia kata dua switch. Maksudnya dua switch yang bergerak, dua switch. Okay. Ini adalah ladder diagram dia. Dua switch Ini dia kata kalau dua-dua tekan baru jalan. Maksudnya dua-dua dalam keadaan normally open. So, bila dua-dua dalam keadaan ini open, bila kanan ditekan tapi kiri tak ditekan, itu tidak akan membuatkan mesin itu bergerak. Oh, saya lupa letak mesin. Okay, mesin di sini. So, ini adalah bus bar dia. Okay. Sebelum tu kita kena tahu address untuk input dan output. Okay, ini saya dah tetap. Ini kita boleh input dan output ni kita namakan dia switch 1. Kita addresskan dia 0.00 sebab saya dah beritahu tadi input dan output input untuk CPU1E E20 adalah daripada 0.00 sampai hinggalah 0.11. So daripada range itu kita boleh letaklah berapa yang nak letak. So input yang kedua saya letakkan nama sebagai switch 2 dan address dia adalah 0.01. Okay, output pula saya letak nama mesin dan address dia adalah 100.00 seperti yang diberitahu sebelum tadi. Address untuk yang kami gunakan adalah CPU1E E20 input output daripada 100 hingga 107. So daripada range ni kita boleh gunalah berapa nak 100.1, 100.2 mana-mana, tapi tidak boleh lebih daripada range ini. Okey. Bila kita dah buat input output ni, so kita ke ladder diagram. Ini adalah ladder diagram yang saya telah buat di software CX Programmer. Okay, seperti yang saya terangkan tadi, ini adalah rang dia. Kita berada di rang kosong, step kosong, dan ini adalah 24 volt bus bar. Sini adalah kosong bus bar. So seperti kita dah letak input dia address 0.00 untuk switch 1, 0.01 untuk switch 2 dan output dia adalah 100.00 untuk mesin. Okey, sepatutnya tiada masalah untuk simulation ni. Dan apabila saya tekan switch 1, akan ada nyalaan hijau di sini dan through ke sini. Okey, tapi saya hanya tekan di sini saja, normally close. So sini adalah normally open. So current tidak akan mengalir melalui switch 2 ni. Dan mesin pun tidak akan menyala. Dan ini tidak menepati soalan yang case tadi yang kita baca tadilah. So kita mesti apabila saya tekan kedua-duanya normally close, so current akan melalui line ini dan terus ke mesin dan mesin akan berfungsi. Okey, oleh itu untuk memudahkan lagi kita akan through kepada CX programmer. So kita tengok sini tak ada problem apa-apa. So zero error, zero warning, so tak ada masalah lah. Okey, yang ini saya katakan tadi di line hijau ini maksudnya first initial condition current telah melalui rang ini. Kalau 224 volt VDC telah melalui di rang ini, tetapi dia berada dalam keadaan normally open. Kalau switch ni tidak akan membenarkan 24 volt VDC ni melaluinya. So apabila saya tekan, saya masukkan nilai 1, dia akan melalui switch 1, tetapi switch 2 ni tidak ditekan dan mesin ni tidak akan berfungsi. Okey, so yang mengikut soalan tadi, dia kata apabila kedua-dua switch itu ditekan simultaneously dan mesin itu baru akan menyala. So saya akan tekan 1 untuk high plus. Dan apabila kedua-dua switch ini ditekan, barulah mesin itu akan berfungsi. Akan tetapi apabila salah satu switch ini ditutup ataupun berada di normally open, kosong ini adalah nilai low, saya tekan, automatically mesin itu tidak akan mendapat current dan mesin itu akan stop. Ini kena dengan kita punya case study, mana switch dia mestilah kedua-dua switch ini menyala, barulah mesin ini akan berfungsi. Okey, itu untuk case study, untuk summarize untuk week 6. Untuk week 7, kami didedahkan dengan PLC instruction. PLC instruction ni more kepada basic untuk kita tahu mengenai CX programmer. CX programmer yang kami guna adalah CX programmer version 9.6. Tetapi sebenarnya ada lagi version yang sama yang dinaikkan sikitlah dia punya sistem. Tapi sama saja fungsi dia adalah untuk run program untuk PLC. Untuk example kali ini saya akan terangkan beberapa function untuk start dan push stop button menggunakan kaedah yang berbeza. Okey, soalan ni dia kata the pulse switch start button is used to start a motor and the pulse switch stop button is used to stop the same motor. Maksudnya ada satu motor sajalah. Assuming the start button is normally open, while stop button is normally closed. Draw the diagram for the circuit controller. Okay, sebelum tu kita keluarkan dulu stop button, start dan stop button punya input. Kita letakkan sebagai 0.00, 0.01 dan untuk output kita letak 100 lah. Ini saya gunakan daripada E20, iaitu 20 input output punya CP1E. Okay, untuk lebih senang faham, dia kata untuk start button normally open. Okay, Untuk pengetahuan, ini adalah simbol normally open contact. Lepas tu dia kata N. N maksudnya dia series. Series dengan normally close. Normally close contact. So bila normally close dia macam ni. Dan terus ke output. Output. So fungsi bila kita simulate. Okay, saya simulate. Bila kita simulate, dia akan mengikut kehendak yang kita program. Seperti yang saya tahu, ini adalah initial condition apabila 24 VDC diberi, iaitu di belah kiri dan belah kanan adalah 0 VDC bus bar. Okay, bila saya tekan switch satu ni iaitu start button, saya bagi high pass, motor akan bergerak. Akan tetapi bila saya tekan push button stop, motor akan berhenti. Okay. Itu adalah untuk push button start biasa. Okay, kita pergi kepada seterusnya. By the ladder diagram, Q1, so the motor should continue to run even though when the start button is released. Dia kata apabila dia nak kita modify, walaupun kita punya push button start ni kita release ataupun kita lepaskan, dia akan tetap, motor ni akan tetap bergerak. So kaedah ini kita akan gunakan kaedah latching ataupun normal latching. Normal latching ini dia adalah fungsi dia adalah dia self holding the internal relay until the stop button is triggered. So dia punya ladder diagram dia macam ni. Okay. Sama je macam tadi. Ini push button start. Normally open, normally close untuk stop. So ini adalah IR. IR ni kita tak boleh gunakan address yang sama seperti output. Sebab dia akan mengelirukan kita tu. So kita senang kita letak selain pada nilai output yang diberi, selain pada 100 ke 107 tu, 100 ke 100.07 kita boleh letak sini sebagai 5, 10 so on. So bila yang ni akan diparalelkan dengan address IR ini akan diparalelkan dengan address start button 0.00. So bila current lalu di start button, bila start button ni triggered, current akan lalu ke stop button sebab dia adalah normally close dan dia akan trigger kepada IR, internal relay. Internal relay ni akan diberi trigger, akan dibagi high pass kepada internal relay di bawah ni dan dia akan bergerak sendiri sehinggalah walaupun start button ni dilepaskan. Okay. Ini latching yang saya lukis tadi. Apabila switch satu ditekan, yang line hijau ni akan melalui S2 sebab dia normally close dan akan trigger kepada IR. IR ini akan terus pergi ke sini dan pergi ke sini dan menggerakkan motor. Dan sama-sama bila saya releasekan switch satu ni, IR ini akan bergerak sehinggalah switch 2 ataupun stop button ni di-trigger. Ini kerana dia ada self holding ataupun latching yang di mana dia memberi impuls sendiri kepada internal relay. So seperti contoh saya tekan satu sebagai high pass kepada switch button. Ni maafkan saya ini switch button. So close. Okay, tengok dia dah motor ni sedang bergerak apabila switch button ataupun start button ni ditekan. Tapi bila saya lepaskan ataupun saya lepaskan switch button start ni, motor ni tetap bergerak disebabkan ada latching ataupun high pass telah diberikan di bawah di internal relay ni, sehinggalah saya tutup ataupun saya tekan stop button barulah berfungsi. Yang kedua, dia suruh kita tukar kepada set dan reset. Set dan reset ni berfungsi sama seperti latching tapi dia menggunakan dua output iaitu set dan reset. Dia dalam keadaan normally open. Okay, ini adalah set. Satu lagi adalah reset. Okay, dia berfungsi menggunakan normally open disebabkan dia macam push button yang biasa. Bila kita tekan ni, yang ni akan set ataupun start, dan bila kita release, dia akan still lagi jalan. Sehinggalah kita menekan butang reset dan kedua-duanya akan diresetkan seperti biasa. Okay, kita akan pergi terus kepada CX programmer kita. CX programmer ni, kalau anda dapat lihat di bahagian reset dan reset ni, saya letak switch button 1 dan switch 2 seperti yang diberi oleh soalan. Start button, stop button. Bila saya tekan start button, motor itu akan berfungsi, dan bila saya tekan, saya releasekan balik, saya lopaskan balik start button ni, motor still berjalan. Okay, ini kerana pas yang diberikan akan sentiasa berjalan walaupun kita berada di low pass. Selagi kita tak beri high pass kepada reset, selagi itulah motor itu akan bergerak. So bila saya tekan high pass, saya akan beri high pass kepada reset, motor akan berhenti dengan serta-merta. Okay. Untuk konsep seterusnya, kita pergi pula kepada keep. Untuk senang faham, keep, reset dan set adalah benda yang sama. Cuma keep ini menggunakan satu blok saja, di mana di dalam satu blok ini mengandungi dua benda yang sama seperti set dan reset. Dia menggunakan normally open kedua-duanya. Kita pergi terus. Okey. Untuk pengetahuan, kalau saya tekan start button di sini, saya hapaskan, dia akan terus gerakkan motor. Okey. Tapi bila saya saya lepaskan balik, dia still berjalan. Sebab apa? Kita tak trigger di bahagian reset button. Okey. So dia, selagi saya tak tekan reset button, selagi itu motor tu akan berfungsi. Okey, sekarang saya tekan reset button. Saya tak satu untuk high passkan dia, triggerkan dia. So motor ni akan berhenti. Tapi kalau saya tekan contoh saya tekan ini, saya kosong dulu. Saya tekan start. Dalam masa sama, saya tekan stop button ni. Saya bagi high pass kat dua-dua ni. Motor akan automatik berhenti. Ini kerana selagi apabila high pass ini, start button ini diberi high pass, selagi dia tidak trigger kepada reset button, selagi itu motor akan bergerak. Tapi disebabkan kita kedua-dua ini dalam keadaan dominant off, so maksudnya apa-apa pun bila saya tekan off, apa-apa tidak akan bergerak. Okay, ini untuk salah satu example lah. Secara kita nak buat ladder diagram, selain menggunakan latching, menggunakan reset, set, kita boleh gunakan ni. Memilih kod bahagian block part ni sebagai satu part yang agak susah untuk saya faham. Ini kerana dia tidak seperti yang biasa, sebab yang biasa dia just satu line saja, round 1, macam mana round 2, macam mana round 3, macam mana kan. So yang bila melibatkan blok-blok ni, saya keliru. Masa satu saya nak ambil belas ABE, ataupun saya kena buat AC dulu ke ataupun BC. So saya setelah saya lihat balik video-video yang Puan Cik Sumayya ni tunjuk, dia menerangkan kaedah yang paling mudah dan senang untuk saya faham, iaitu kaedah dia untuk membaca ladder diagram ni daripada left to right, daripada A to B to E, top to bottom. Top to bottom tu A, B, lepas tu C, D. Okay. So dia kata kalau untuk blok ni kita solvekan satu blok dulu. So satu blok mengenai dua ladder diagram, dua load. So sini satu, sini satu. Okey. Bila dah settle dua-dua ni, kita boleh jadikan dia seperti satu satu lot yang dalam keadaan series. So ini adalah output. Okey. Macam mana saya nak settlekan ni? Saya tengok pada left to right. Okey, left to right, blok pertama. Ni blok pertama, ni blok kedua. Okey, blok pertama adalah A dengan B. Okey. Kat A ni adalah N. N adalah N load. Ni adalah load. Load sebab dia mula-mula kan. Load. Lepas tu N not. Okey, tu blok pertama. Lepas tu load. Blok kedua load. Yang D ni ada load. N load lah. Ni N not. Ini N load. So, bila kita dah serieskan dia, bila kita gabungkan, dia akan menjadi all load sebab dia dah dalam parallel. Bila dah all load, baru kita end kan dia. Dan seterusnya pada out. Okay. Untuk saya yakinkan lagi dengan saya punya cara saya, bacaan saya mengikut plug ni, saya lakarkan balik layar diagram ni ke CX programmer dan di situ dia memudahkan saya untuk double check di sini. Kita dapat lihat okay, di sini saya dah lukis sama macam dalam soalan tadi. So saya senang je, saya pergi dekat view ni, saya jumpa record ni, saya tekan, dia akan terus keluar. So saya dapat double check lah sama tak dengan saya punya jawapan menggunakan teori. Bila sama maksudnya betul lah saya punya layar diagram punya manual code tu. Itu saja dari saya.
Assalamualaikum warahmatullahi wabarakatuh and good afternoon to everyone. My name is Ahmad amirul afiq bin Mohammad fauzzi, matric number CN190130. So for my part, I will summarize from week 9 until week 12. As you can see right now, during week 9 and 10, the student need to do group assignment. So the students were distributed into 13 groups. Each group consists of 3 members. The topic for assignment is PLC Design Project, Industrial Application. This is figure of my group assignment. So during the group assignment, I was in group 1 and we choose liquid laboratory as our group assignment title. So the function of liquid laboratory is to watch the extent of liquid within the tank. The operation for my project is the system has an automatic pumping system attached there to so on refill the tank once the liquid gets to the lower threshold, while offering the pump once the liquid gets to the upper threshold. This water level monitoring control and maintain the water level within the overhead tank and ensure the continuous flow of water around the clock without the strain of getting to switch the pump on or off, thereby saving time, energy, water, and stop the pump from overworking. Next, I will summarize for week 11. During week 11, it was held an alumni industrial talk, PLC and SCADA application from industry perspective and experience sharing. This alumni industrial talk was held on 1st June 2021. This industrial talk was held from 8 p.m. until 10:15 p.m. The invited panel are Natasha Amira and Muhammad Syukur A. Rahman. During the alumni industrial talk, the first panel is Muhammad Syukur A. Rahman. He worked at Ahmad Technology Sdn Bhd, which located at Ulu Tiram, Johor Bahru. Currently, his position in electrical department is as a programmer. So his responsibility and duties such as to supervise machine assembly and installation, responsible for all electrical activities in job site and assembly area. And last, preparation of project quality plan, project report, and documentation. After panel 1, panel 2 is Natasha Amira binti Abdul Rauf. She worked at Presik Technologies Berhad at Johor from December 2019 until January 2020 as quality analysis engineer, and then she worked at Protect Control System Sarawak from January 2020 until February 2021 as system engineer. And last, she studied at University International of Malaysia UTHM in March 2021 and continue her studies Master in Engineering Technology KNT. After the alumni industrial talk, the student need to do individual assignment. They need to submit short report in 1 until 2 pages. So during the alumni industrial talk, they need to ask question or giving opinion during Q&A. So as evidence they asking during the Q&A, they have to screenshot and state it in the short report. To self-learning based on the example that given by our lecturer. The example that our lecturer gave to us is PLC application. So there are 5 examples. So the first one is PLC conveyor motor. Second, semi-automatic liquid mixing application. Third, sequential motor control. Fourth, latching circuit. Interlocking motor control. And for the next part, I will explain the detail each of the PLC application. The first example for PLC application is PLC conveyor motor. This is the example of figure PLC conveyor motor. It consists of start button, stop button, green indication lamp, red indication lamp, motor, and proximity sensor. For the next figure is when start button pressed, motor will be started, and the green lamp indication will be activated. If the motor start running, so the box will start move. Once the box getting near to the proximity sensor, the motor will be stopped. And green lamp indication will be deactivated while red lamp indication lamp will be activated. For the input and output of the example is, so the first one is input. So the input is start button 0.00, stop button 0.01, and proximity sensor 0.02. So for the output is motor 100.00, run for indication lamp in green color 100.01, stop, which mean for red lamp indication lamp 100.02. Next, we move to process sequence description in simple narrative. So for the first step is input. So start button is pressed, while output is motor will start running. At the same time, the green lamp will turn on. For the second step, the input is proximity sensor detect the box. Output is motor will be stopped, green lamp will turn off. At the same time, red lamp will turn on. The third step is once the stop button is pressed, the motor will stop. This is a ladder diagram for PLC conveyor motor. It consists of start button, stop button, proximity sensor, internal relay, motor, run indicator in green color, stop indicator in red color. So at the rung 0, by pressing the start button will activate IR1. Pressing e-stop or stop button or proximity sensor detect box will be deactivate IR1. At the rung 1, motor and run indicator turn on if start button is pressed. At rung 2, stop indicator will turn on if emergency stop or stop button is pressed or if motor stop. We move to the simulate and analyze of the ladder diagram. So as you can see, this is the figure of the diagram. When power supply is supplied to the system, at round 1, motor stop due to there are no current flow, while at round 2, current flow to IR1 normally close contact and stop indicator turn on. Okay, this is figure 2 of the ladder diagram. When start button is pressed at rung 0, IR1 coil active high, IR1 normally open contact will close and allow current to flow even if start button is released. And at rung 1, motor will start running and run indicator turn on. While at rung 2, IR1 normally close contact will open and stop indicator turn off. We move to the third figure. When the emergency stop or stop button is pressed at rung 0, the current will be interrupted. Coil IR1 active low. IR1 normally open or normally close contact back to normal condition. At rung 1, motor will stop and run indicator will off. At rung 2, stop indicator on. So this is the last figure. When system is on and proximity sensor detect the box, at rung 0, the current will be interrupted. Coil IR1 active low. IR1 normally close or normally open contact back to normal condition. And at rung 1, motor will stop, run indicator off. At rung 2, stop indicator on. Okay, this is the second example in PLC application, which is semi-automatic liquid mixing application. So this is the diagram of the semi-automatic liquid mixing application. In this application, pure unmixed solution can be prepared by the operator using switches switch 1 and switch 2, and mixed solution or material can be prepared by the operator using switch 3. Switch 1 is used to activate valve 2 while switch 2 is used to activate valve 4. The interlock system is provided so operator cannot operate both switches at the same time. The operator will observe the level of the tank and he can discharge the liquid inside the tank by operating valve 5. The agitator motor 1 will be in running mode while tank is being filled. Valve 1 and valve 3 and valve 5 are manual valve which is not connected to the PLC. Valve 2 and valve 4 are electronically operate valve which can be controlled by the PLC. So, the input and output for this application is, the input is switch 1, the operand is 0.00, switch 2, 0.01, switch 3, the operand is 0.02, while for the output is valve 2, the operand is 100.00, valve 4 100.01 and motor 1 100.02. Next, this is the truth table for this application. Switch 1 is used to activate valve 2 and motor 1. Switch 2 is used to activate valve 4 and motor 1. Switch 3 is used to activate valve 2, valve 4 and motor 1. The interlock system does not allow the operator to operate both switches at the same time. I will explain a little bit about the ladder diagram of this application. So at the rung 0, it consists of normally closed switch 1, normally closed switch 2, normally open switch 3, normally open switch 1, normally closed switch 2, normally closed switch 3, and the output is valve 2. While at the rung 1, it consists of normally closed switch 1, normally closed switch 2, normally open switch 3, normally close switch 1, normally open switch 2, and normally close switch 3, and the output is valve 4. While at the rung 2, it consists of valve 2, normally close valve 2, and normally open valve 2, and normally open valve 4, and the output is motor 1. And now, I will explain about the simulation and analyze about the ladder diagram of this application. So at the upper left of this diagram, when switch 1 is triggered at rung 0, valve 2 open to refill the tank with liquid 1. At rung 1, due to the interlocking system, switch 1 normally close contact will open and there are no current flows. While at rung 2, when valve open, motor will on. Okay, we move to the upper right of this diagram. When switch 2 is triggered at rung 0, due to the interlocking system, switch 2 normally close contact will open and there are no current flows. But at rung 1, valve 4 open to refill the tank with liquid 2. And at rung 2, when valve 4 open, motor 1 will on. Next, at the lower left of this diagram, when switch 3 is triggered at rung 0, valve 2 open to refill the tank with liquid, while at rung 1, valve 4 open to refill the tank with liquid 2. And last, at rung 2, when valve 2 and valve 4 open, motor 1 will on to mix both liquid 1 and liquid 2. And lastly, we move to the lower right of this diagram. When more than one switch is triggered simultaneously, switch 1 and switch 3 is triggered, output valve 2, valve 4 and motor 1 does not operate. The third example in a PLC application is sequential motor control. In this case, the motors need to operate sequentially. There are total 3 motors to be controlled in a sequence. Each motor will start sequentially. Firstly, motor 1 will start, then after some delay, motor 2 will start, and after some delay, motor 3 will start. The whole operation will take 10 seconds to start all motors in a sequence. By providing this delay, it could help to avoid the problem of taking large current by motors during initial startup. All motors will be operating in this sequence and 5 seconds time delay is to be provided between operation of each motor. We move to the input and output for this application. So for the input is start button, the operand is 0.00, stop button, the operand is 0.01. While for the output is motor 1, the operand is 100.00, motor 2, the operand is 100.01, and lastly motor 3, 100.02. The method used in process sequence description is simple narrative. For the first step, at the input section is start button is pressed. At the output section, motor 1 will turn on. At the same time, timer 001 activate for 5 seconds. At the second step, the input is timer 1 times up. At the output is motor 2 turn on. Timer 002 activate for 5 seconds. At the third step, timer 2 times up. Motor 3 turn on. At the fourth step, in the input section, stop button is pressed and the output is reset all operation. This is the ladder diagram for this application. So at the rung 0, we can see that it starts with start button and then it consists of stop button and internal relay, while at the rung 1, normally open internal relay, the output is motor and we use timer 001 and the set value is 5 seconds. So at the right diagram, we can see that at the rung 2, it consists of normally open internal relay and normally open timer 001 and the output is motor, and it consists of timer 002 and the set value is 5 seconds. While at the rung 3, it consists of normally open internal relay, normally open timer 002, and the output is motor 3 and the operand is 100.02. And now we are at simulate and analyze part. So at the left diagram, when start button is pressed and released, at rung 0, internal relay coil active high, and internal relay normally open contact will close and allows current to flow even if start button is released. At rung 1, motor 1 will start running and activate timer 001 for 5 seconds. While at the right diagram, after timer 001 activate, at rung 0, due to latching, internal relay coil remain active high and internal relay normally open contact will close and allows current to flow. At rung 1, motor 1 remain on, while at rung 2, motor 2 will start running and activate timer 002 for 5 seconds. We move to the next diagram. At the left diagram, after timer 002 activate, at rung 0, due to latching, internal relay coil remain active high and internal relay normally open contact will close and allows current to flow. At rung 1, motor 1 remain on. At rung 2, motor 2 remain on. While at rung 3, motor 3 will start running. And now we look at the right side of the diagram. When stop button is pressed, at rung 0, current will be interrupted. Internal relay coil active low. Internal relay normally open contact will back to normal condition. It will reset all the system. The fourth example in PLC application during week 12 is latching circuit. The operation of this latching circuit is when start push button is pressed, current will flow through normally closed stop push button and activate motor starter coil. Hence, latching circuit normally open contact M will change to close. When start push button is released, current still flows through latching circuit M and activate motor starter coil. When stop push button is pressed, the current is interrupted, motor starter coil deactivate and latching circuit M back to normal condition. And lastly, the fifth example in PLC application during week 12 is interlocking motor control. There are three motors, motor 1, motor 2 and motor 3, each with its own start and stop button. The system only allows any two motors to run at one time. The input and output for this application is, for input, start push button motor 1, the operand is 0.00. Stop push button for motor 1, 0.01. Start push button for motor 2, 0.02. Stop push button for motor 2, 0.03. And lastly, start push button motor 3, the operand is 0.04, and stop push button for motor 3, 0.05. While for the output is motor 1, the operand is 100.00, motor 2, 100.01, motor 3, 100.02. The sequential tasks interlocking motor control are as below. First, start push button M1 is used to activate motor 1, while start push button M2 is used to activate motor 2, and start push button motor 3 is used to activate motor 3. Any two motor will run at the same time. Next, we move to the ladder diagram of this application. At rung 0 is for motor 1, while at rung 1 is for motor 2, while at rung 2 is for motor 3. In simulate and analyze part, at the left diagram, when start M1 is triggered at rung 0, motor 1 will start running. While at the right diagram, when start M2 is triggered at rung 0, motor 1 remains running, interlocking motor 2 will open and current flows through interlocking motor 3. At rung 1, motor 2 will start running, interlocking motor 1 will open and current flows through interlocking motor 3. We move to the next diagram. Look at left diagram. When start motor 3 is triggered at rung 0, motor 1 remains running, interlocking motor 2 will open and current flows through interlocking motor 3. While at rung 1, motor 2 will start running, interlocking motor 1 will open and current flows through interlocking motor 3. And last, at rung 2, motor 3 does not operate due to both interlocking motor 1 and motor 2 in open contact. So at the right diagram, when stop motor M1 is triggered, at rung 0, current is interrupted, coil motor 1 back to normal condition and motor 1 stop running. At rung 1, interlocking motor 1 will close, current flow through it and motor 2 remain running. At rung 2, motor 3 will start running due to interlocking motor 1 become close contact. Okay, I will continue for my part. So this is the basic ladder diagram. As we can see, there is an error on the CX programming. Figure 1 shows a red line on the rung 0. The red line will appear as Work Online Simulator is clicked. After we click the Work Online Simulator, from the compile section, it will show whether there is an error or not. Based on the figure, it shows that no output is connected for the rung 0. So, the solution is the motor will be added and act as output. Now, I will talk about hardest instruction. So, for me, the hardest instruction is set and reset instruction. Set and reset instruction is one of the sequence output instruction. The other example of sequence output instructions such as keep and output. So as you can see, this is the symbol of set, and then this is the symbol for reset. The function of set is turn the operand bit on when the execution condition is on and does not affect the status of the operand bit. When the execution condition is off, use reset to turn off a bit that has been turned on with reset. Okay, for the reset function, reset turn the operand bit off when the execution condition is on and does not affect the status of the operand bit when the execution condition is off. Use set to turn on a bit that has been turned off with reset. There is precaution when using set and reset instruction. Set and reset cannot be used to set and reset timer and counters. Finally, the conclusion for the whole semester from week 1 until week 12, the students able understand about the ladder logic instruction. Second, student getting familiar with the Omron, CP series, CPU1E CPU units. And lastly, student can demonstrate the diagram using CX programmer. That's all from us. Thank you.